Hello teammates, it's Mr. Ninny coming to you with another physics bunker production. We're going to look at FRQ number 4. My numbering system might be a bit off. I need to get that straight in the next couple days. So this is the one assigned on the 28th of April. Has to do with electric and magnetic fields. Easy money. So you're given particle positive charge, moving it in the plane of the page. In the plane of the page. This would be perpendicular. In the plane is like that. Let me turn my phone off. Yeah. Constant uniform field. Effects of gravity are negligible. It's good. Let's answer the question. Part 1. Electric field towards the bottom of the page. The question doesn't ask you to draw the field lines. I think that helps visualize. Let me get this in the view. You know the electric fields go positive to negative. You know that the proton's positive. It's gonna, when it enters the field, it's gonna feel a force in the down direction. It's gonna be a constant force. Because you recall that force electric equals Q times the electric field. Electric field's constant. And you know that from the parallel lines, you know it's constant. And, well, it was in the statement, but just so you can recognize that. Yeah? So you got a parabolic arc. And why I say that, it's because you're going to read the entire question. And then you're going to answer the parts of the question, because you're going to see later, you saw later in the question, it asked you to explain which one of those, if any, could be similar to a projectile. And recall your projectile motion days that if this is a horizontal launch angle, I'm okay. You'd have a parabolic arc. It's good, and that's going to help you reason through. Constant force gives you constant acceleration, gives you the parabolic arc. Easy 2 points. Easy 2 points. Now you may be wondering why I mentioned projectile motion. Recall, AP Physics 2 is based on the assumption you've mastered the skills in AP Physics 1, so you can see stuff that you saw pop on. Now you got a magnetic field. Draw a possible path of the projectile, and it's different, isn't it? Because the force direction changes. So when you've got a positive charged object, it's going, point your finger in the direction of the velocity, point your middle finger in the direction of the field, so the field is up, and so you're going to feel a force down initially. But then what happens when the projectile is here? That force, you got a centripetal force, don't you? So you don't have to draw these on your solution, but I think that helps. So you got a different shape. You have more a semicircular shape. So uniform field, it's going to move in a circle, and since that's in the middle, and we don't know what the force is, but we're going to represent, that would be the center. And so you're going to have a different shape of your magnetic field. So always read carefully and think, what are they trying to assess me on? That's weird. Oh. Low battery. Teammates, I'm going to keep shooting. I'm sorry. I'm very sorry. I'm going to just keep, because I got to get this posted. The low battery, so my screen went dull. We'll get done. All right. For which of the previous situations, oh, there we go. I just talked about that. So again, when you're faced with this, you're not just going to say the electric field. You want to explain why it's the electric field and why it's not the magnetic field. Complete statements. They're going to rope-a-dope you in which they ask you why. You got to, I mean, they're kind of inviting you to explain. You just can't write E field. You got to explain the why. Is good? Last part. This is actually the meat of the question. So the parts above. So A, I, double I, triple I are really just to get the juices flowing. They're just to get you to thinking. So this is the meat of the problem. It's a paragraph length response. So one of your questions on the AP exam is going to be a paragraph length response. It could look like this. And that's where the meat of the question is. So, and we know the order of the questions. We know that the first question will be a qualitative, quantitative translation question. And we know the second question is going to be a paragraph length response. So if you're faced with a question like this, know that they're focused on the paragraph length response. And so we're given another region of space contains an electric field directed up, magnetic field out of the page, both fields constant uniform, horizontal beam of protons. So I would write to remember that's a positive charge. Protons exit, they either exit at point 1 or point 2. And you've got to explain your reasoning in a coherent paragraph length response. Explain the why. Explain the why. So here's the key points. And if you'd like me to model a paragraph, let me know. I think everyone can write a paragraph. You want to break it into parts. You want to compare. Make sure I'm in the screen. Compare and contrast. Right? Everybody's had an English class or two. Compare what's similar, contrast what's different. I think that's a good framework. I think claim, evidence, reasoning is a good framework. So apply your English skills to work. Key points. Force electric, force mag, act in opposite directions. That's a contrast. Force mag's affected by speed. Force electric's not. Another contrast. Different paths because of the addition of forces. That could be a compare. Right? Because you've got the particle, your proton's going to be affected by both the electric force and the magnetic force. So you got two forces acting on one object. Those forces are going to, it's almost like a superposition problem, isn't it? When you've got a particle being acted on by two different forces. But in this case, the nature of the forces themselves are different. Right? So again, force, and you can come back to your principles. Force electric is Q times E field on your equation sheet. Force mag, QVB sine theta, and compare and contrast. Example, why the charges are the same. This reacts to E field. This is affected by velocity. I'm sorry, this is affected by E field, that by B field. This is affected by velocity, while this is not. As the velocity increases, the force magnetic increases. And the reason through why the slower protons exit at point 1 and the faster ones at point 2. And tie it all in a coherent paragraph. Teammates, if you're given so question 2 on the exam, we know it's going to be a paragraph length response. You can't answer that in bullets. I think it's fine if it's problem 1, you can answer in bullets. But they want to see a coherent paragraph. It's good? All right, teammates. This was 5 points. This was 2, so 5, 6, 7. The E field one was 2 more, so 8, 9, and AIII, which one most like projectile motion? That was 1 point. Hot diggity dog, teammates! I'm gonna get this posted out here.